In this problem, the descending pulley has a radius 20 centimeter and moment of inertia 0.2. So this pulley, actually you have to take it as a ring. That means if the for the ring, the radius is r, the mass is m, moment of inertia is equal to mr square. And so say this is m, and say this mass of the block be capital M. Fixed pulley is light, so that's a light pulley, fixed pulley. Find the acceleration of the block if its mass is this. So again I will use the energy method in this. As you know, this block of mass capital M, so you have to find acceleration of the block. So suppose this block goes by a distance x and in turn gains a speed v and an acceleration a. So in the same time, as you know, the pulley will go a distance x by 2. Now that's quite easy, you know, this we have done all these constraint equations and this thing. So this pulley, you know, this will have a tension T, and there, or rather, you know, if this goes down a certain distance, suppose this goes down a certain distance y, then you know this block has to go a distance is equal to 2y. And also you can think it from here. Suppose it has a velocity v, so for the pulley this end has a velocity v, while as this string is at rest, so this end of the pulley will be at rest. So this end the velocity is 0, so the center of mass will have a velocity v by 2. As you know, the velocity of the center is equal to velocity of the ends by 2. It's a vector sum. So midpoint theorem. So that means the pulley, this end has velocity 0, this end has velocity v, and the midpoint has velocity equal to v plus 0 by 2, so that is v by 2. So obviously this will go down x by 2, and this has velocity v by 2 and angular velocity omega that we can find. So you know this end or this end at rest, so this is the instantaneous axis of rotation. So this angular velocity of the pulley is v by 2 divided by radius of the pulley, so v by 2r. So now we can use this energy equation, that loss in potential energy is equal to gain in kinetic energy of the system. So loss in potential energy of this pulley, it goes down a height x by 2, so it is mg x by 2 equal to kinetic energy. The pulley has kinetic energy half m v by 2 square, translational kinetic energy, plus half I into omega, which is v by 2r square, plus this, the block also gains kinetic energy, it has got speed v, so half capital M v square. So therefore we can write mg x by 2 is equal to half, you can take common, so it is m by 4 plus I by 4r square plus capital M times v square. So therefore, so this 2 and 2 will cancel, so v square is equal to mgx divided by m by 4 plus I by 4r square plus capital M. So again you can differentiate it with respect to time. So 2v dv dt is equal to mg dx dt divided by this whole thing, m by 4 plus I by 4r square plus capital M. So now you know v is equal to dx dt, so that will cancel. So therefore dv dt, that is acceleration of the block. dv dt is half of so mg divided by m by 4 plus I by 4r square plus capital M. So just a bit of simplifying this will make it, so 4 make it 2 mg divided by m plus so I by r square plus 4 capital M. So thus in this way you can solve. So the key thing in the problem is that one, you have to consider this as a ring, so moment of inertia is mr square, and the most important thing is about the velocity. So I am discussing it again for the sake of understanding better. This is the pulley. See, this string is at rest, so this point on the pulley also is at rest because there is no slipping between string and the pulley. The block having velocity v, so this string has velocity v, so this string has velocity v, no slipping, so this point on the pulley also has velocity v, the left end point. So therefore if you see the pulley, this point velocity is 0, this point velocity is v, so the midpoint will have velocity v by 2, because you know midpoint theorem about the coordinate of the midpoint, coordinate of the center is x1 plus x2 by 2, and so will be the velocity. Vc is v1 plus v2 by 2. So now, so this velocity 0 becomes the instantaneous axis, so the angular velocity omega, so this will be radius r, so this omega will be v by 2 divided by r, so omega is v by 2r. So this is the key thing in the problem. This is the key part in the problem.